Skittles, everyone's favorite non-chocolate treat. They're downright irresistible, but do you know how they're made? Skittles start out as nothing but goo. They are first formed into flavored spheres in order to get that unique Skittles shape. And from the start, they are separated into different flavors, though they all look the same. Before they're colored, they're called lentils, and they just all look like dark brown niblets. The coloring process for Skittles takes about 4 to 8 hours, depending on the Skittle. They're coated multiple times in paint, and this is what forms the hard shell around the Skittle. Take your Skittle, crunch it, smash it, do whatever, and see the difference of texture between the toffee and the hard shell around it. Neat, right? After the coloring, Skittles are put into a blending belt where they are blended together in order to create a variety of flavor. If you open a fun size and get just yellow, it's because the blending belt didn't do its job. After blending, Skittles are packaged and sent out to the world just for you to eat. Thanks, Skittles. Okay, so I filmed an earlier little notebook thing, but it was like 4 minutes long, so I'm just gonna review what I did, and here we go. Alright guys, today we're doing chem review, and we're gonna find the pH of a Skittle, or really 10 Skittles in 1 liter solution. Let's get to it. A quick review, pH is on a scale of 0 to 14, with more acidic solutions being 0 or closer to 0, and more basic solutions being closer to 14. This is important to remember, as I'm sure you do. To find, the pH of a solution, first we have this formula, which is pH equals negative log of the concentration of H plus ions in a solution. To find this value, first we need to find the molarity of a solution, which I know is horrible, but we're going to do it anyway. A quick reminder, molarity is the value of moles over liters in a solution. I found out that 1 mole of Skittles is 1,367 grams, because the chemical composition of Skittles is C48, H86, and O44. If you remember, we add up all these values to find the amount of grams 1 mole of Skittles would equal, and it's that. It's a large number, so we're going to have to limit our Skittle value. I picked a random number 10 to find out the pH of this acidic solution. So we have 10 Skittles to 1 liter of water. Sounds great, right? 1 Skittle is about a gram. I found this on the internet, and it's close enough to a gram to not be significant, so it's great. So first, to find molarity, we need to find the amount of moles 10 Skittles is in comparison to this number. Remember, in order to find that, we just divide 10 by 1367, which we find out equals 0.007 moles. Now we have our amount of moles that 10 Skittles is, and we can plug it into the molarity equation. So we just do 0.007 divided by 1, which is just 0.007, and we get this number 7 times 10 to the negative third. Now that molarity and our H plus ion concentration are basically interchangeable, and they're the same value, so we just plug this number into our log formula, which equals, as you can see, 2.15. Hope you guys have an amazing day, and I hope you enjoyed the rest of the video. Now, let's turn to Neve so we can learn about solubility.
Hello and welcome to how Skittles are colored. Skittles have 5 main dyes. First one is blue 1, also called brilliant blue. The second is blue 2. Third, red 40. The fourth, yellow 5. And the fifth, yellow 6. All of these colors are soluble in water, so that means that they can be dissolved. See, all 5 of these dyes are denser than water. So if you put a Skittle in a cup of water, then the dye will seep out into the water, but it won't be mixed with the water because the dye is denser, meaning it'll stay at the bottom. For example, if you drop Skittles in water, this will happen. You can see the colors start to seep out, but they also stay at the bottom because they're denser in water.